Problem 6-82. Change each of the following equations from logarithmic form to exponential form, or vice versa. We have 4 problems here, and we're looking to just change the form. Let's do a little recap here, because I think that there's some people who may still be a little lost as to what all this means. If we think about going all the way back to exponential functions, remember, a logarithmic function is the inverse of an exponential function. So an exponential function in its base form, we would say y equals b to the power of x, in which case we would plug in a value here, and we raise it to whatever this power is, and then we would get an output. Okay, remember these ones kind of, if we had a little graph, they would, whoops, didn't mean to do that. These ones would come along and they would shoot up exponentially, or they would have exponential decay and they come down and they just run right along that x-axis there. So exponential growth and exponential decay. Then we started studying inverses. So we wanted to know what the inverse of this function would be, and one method we learned was we can take x and y and swap them out. So when we do that, we would end up with x equals b to the power of y. This was our first form of an exponential function. This is what we called, of a logarithmic function. Ooh, I tripped up there myself. So this is the exponential form of a logarithmic function. This is a log. Why is it? Because our output, our y value, is an exponent. Remember up here, our exponent was our input, but now our exponent is our output. What this graph ended up looking like then was the inverse. Remember, it was like a reflection of that line y equals x. So it would end up coming up and going out like this. Okay, and it would not cross. Remember, we swap our domains and ranges and everything there. Okay, or it could end up doing the opposite here, going this way. Okay, now if you don't really understand what the graphs look like, that's okay for now, but it's something that I feel is important to know. But I don't want to go back too far here into the basics, just because I want to make sure that we're understanding the skill that we're trying to apply in this problem. So this is what we call the exponential form. Now, the problem with exponential form, let's say you wanted to graph on a calculator, we don't know how to set it up or solve it when we have our output or our variable, our y, in the exponent. So they came up with this form here using patterns and rules and things here. They came up with what we call log form or logarithmic form. And there's all kinds of little tips and tricks and things there that teachers teach to go from one to the other and back. But what I try to focus on is this. If you have log form, then you definitely have the word log written in the problem there. Okay, this is how I know it's in log form, because I see the word log in it. Now b is our base here, and y is our exponent. So this log, if we're trying to figure out what base it is, well, the base does not change. We take that b and it becomes our base, and that's that little subscript value down here. The whole point of this form, though, was to give us a way to write an equation where our output was y. So our exponent is always this value that's out here by itself. Okay, this was our way of changing the exponential form, or the inverse of an exponential function, into a form where our output was our y again, because that's what we're used to. And that leaves our x here, which kind of is normally like our outcome here. So we'll just throw that in right here. Now, some teachers teach, to go back and forth. You do the around the world thing. That's great, as long as you remember it and you remember which way you're going there. I just like to remember the fact that my base is my base. If I'm in log form, then I have log written there. If I'm in exponential form, I just have some expression raised to a power. Either way, my base is my base. If I'm in log form, my exponent, I remember this is the way that we came up with so that we could set our exponent or isolate our exponent. So my exponent goes from exponential form to becoming kind of like my output here. And pretty much that leaves x just kind of falling in where it needs to go. But if you can remember two of the three, the third one's easy because it's process of elimination. So that's just a little background. Hopefully, if these are both what I would say here, these are both logarithmic functions. These are both logarithmic functions. This was an exponential function. These are both the inverse of this exponential function, just written in two different forms. Same way you would write, a linear function in standard form, or you could write it in slope-intercept form. Okay, this is just a different form for a logarithmic function. I'd write that all in here, but I have trouble writing sideways sometimes. So let's get into the problem. Let's look at letter A. Letter A tells us A equals log base B of 24. So the first thing I'm going to do here is I'm going to identify that this is in log form because I see the word log in it. It's pretty easy if you think about it that way. So it wants us to go from log form to exponential form. So I'm going to take this here, and the first thing I'm going to identify is what my base is. So if my base is here, I'm going to rewrite my base in my other form. So my base here is B, so I know that I'm going to be taking B, and I'm going to be raising it to an exponent. Now, where does my exponent come from? Remember, the exponent is that value that is by itself, okay, when we're in log form. So it's not going to be 24. In this case, even though it's written the opposite direction here, it's A. So we're going to say B to the power of A should equal whatever our outcome here, or whatever our leftover would be 24. So there is our answer for letter A. Let's look at B now. Letter B. We have 3x is going to equal log base 2y of 7. Again, what form are we in? We're in log form because we have log written in there. So the next part of this here, we're going to look at our base, identify what our base is, and our base here is going to be 2y. I'm going to go ahead and write down my 2y. Next thing I want to identify is what my exponent is. Remember, it's the value that's out by itself. In this case, the value that's out by itself on the other side of the equal sign is 3x. So I'm taking 2y and I'm raising it to the power of 3x. That should equal whatever we've got left over here, our x value, which would be 7. So for letter B, we should get 2y raised to the power of 3x equals 7. All right, let's move along now. Let's look at letter C. Letter C, we're going to have 3y equals 2 raised to the power of 5x. Now immediately you should be thinking about, well, what form is this one in? This one looks a little bit more confusing because it doesn't look the same as the other two. Or maybe it looks easier to you if you're more comfortable with this way. So I don't see the word log, which means I'm not in log form, I'm in exponential form. That means that something should be getting raised to a power. So let's look at this equation, and I see that I have 2 being raised to the power of 5x. So that means that 2 is going to end up being my base. So when I'm going from exponential form to log form, the first thing I do immediately is I write the word log. Then I look, I identified my base. My base here is 2. And then remember the exponent. 2 is being raised to the power of 5x. That's the part that's by itself. And then we're going to have a 3y in here. So we're going to have log base 2 of 3y is equal to 5x. Take a look at it there. Hopefully that makes sense to you. Now let's move on to letter D. this problem, we've got 4p is equal to the quantity of 2q raised to the power of 6. Again, there's no log in here, which means that we're in exponential form, and we're trying to go to log form. First thing I'm going to do, I'm going to write log in there. Which one of these is being raised to an exponent? Well, 2q is being raised to the power of 6, which means 2q is my base. So I have log base 2q. And we're going to say the outcome is 4p and that our exponent is 6. So remember, 6 is over here and our 4p ends up being right there. So we get log base 2q of 4p equals 6. That is our answer for letter D. Once you master the ability to tell these apart or to go back and forth between the two, it makes logarithms much, much easier to work with and to understand the rest of the concepts and properties. Hopefully this helped you out. This is problem 6-82. If you have further questions, I would ask my teacher if I was you. Thanks for watching.